Okay, so here's 8C from your cumulative review, and this is asking about local max and min values. And of course, local max and min values, what we need to do is we need to look for the first derivative, right? And we need to find the critical numbers, okay? The critical numbers. And if we do a sign analysis or if we do a second derivative test, we'll be able to tell where the local max and min are. So there's two ways. You could do sign analysis on the first derivative, or you could go ahead and find the second derivative and plug those critical numbers in. And if you have a positive value when you plug the critical number into the second derivative, that means it's concave up. Therefore, there's a local min. If you have a negative value when you plug the critical number into the second derivative, you have a local max. And if the critical number, when you plug it into the second derivative, gives you a 0, you have neither a local max or min. So let's be aware that we are actually looking for x values between negative pi and pi. Negative pi over 2 and positive pi over 2. So here's 0. So between negative pi over 2 and positive pi over 2. We'll keep that just in mind. So finding the first derivative, I think, should be fairly straightforward here. Let's just see. Derivative of sine is cos x, and the derivative of cos is negative sine x. So this is plus sine x. Does that look good? Now, if we let this equal 0 to solve for our critical numbers, find our critical numbers, what we end up with here is 0 equals plus sine x. So I have like negative cos x equals positive sine x. So we could stop right there and say, okay, for what values do we have cos and sine the exact same value, but one is positive, one's negative? And that's the angle we're looking for. You could do that, or like you asked there, what we could do is divide both sides by let's say cos. So you'd have a negative 1 equals sine x over cos x. And what is sine x over cos x? That's tan x. So that's where they get the tan x from. Now, going from here or going from here, I will show you how to look at the unit circle, and we'll grab that unit circle from the last question we did. So between negative pi and positive pi, so that's between, let me use my red marker here, that's between, if this is 0 right here, that's between this value and this value. So stopping at this point, you say to yourself, where is the value for cosine and sine the exact same number but opposite sign? And I'm going to look and I'm going to say same number opposite sign, same number opposite sign. Oh, look at this. Same number opposite sign right here. Okay? And so what is that? Well, you might say, oh, that's 7 pi over 4. Nope, it's not. Because 7 pi over 4 is way over here. That's out of our interval. That's out of our domain. So actually what we need to do is go back from 0 and say this is negative 1 pi over 4. Okay? Negative 1 pi over 4. So our only x value that we're looking for is negative pi over 4. So that's our critical number. That's our critical number. So yeah, so from there, you have the two options, remember? You could do sign analysis on the first derivative, which, let's see, might be kind of tough because the first derivative just has a sum of things here, and can you write this as a factor of two things? Oh boy. The other option is to find the second derivative and plug this number into the second derivative, which probably I would suggest. So the second derivative, let me zoom out here a bit. The second derivative is just the derivative of the first derivative. So the derivative of cos is negative sine, and the derivative of sine is cos. Does that look good? Does that look about right? Okay, so now what we do, that was easy actually, wasn't it? That wasn't bad. So what we do now is we simply plug negative pi over 4 into the x value. So negative, is that red okay? Ooh, that red is bad. Didn't realize that. Can you grab the lights for us back there? Yeah, just a couple of them, just so it's, thank you. Not enough so that we all fall asleep, but you know, that's perfect. Okay, so watch this. I'm going to put negative sine of negative pi over 4 plus cos of negative pi over 4, right? So what does that yield us? Negative pi over 4 is, for a sine value, is negative root 2 over 2. So I have negative root 2 over 2. That's what this is. So this right here is negative times negative root 2 over 2. And this one over here, cos of negative pi over 4, is the cos value is positive root 2 over 2. Now, the value doesn't matter so much as the sign, right? So if I'm adding this, it's just positive root 2, isn't it? Positive. The only thing you're concerned about is the positive or negative nature of that value. And so because this is concave up, guess what this critical number yields us? It's a local what? Minimum. Yeah. So, going back to the question, find the local maximum and minimum values. It appears that we only have a local minimum, a local min, at x equals negative pi over 4. And if they want the y value, okay, then you have to put negative pi over 4 into the original function, okay? And we can do that. So the y value is going to be sine of negative pi over 4, which is negative root 2 over 2 minus cos of negative pi over 4, which is positive root 2 over 2. So negative root 2 over 2 minus root 2 over 2, which is just negative root 2. Does that look good? So that's the y value. So x is negative pi over 4 and y is negative root 2. That's the point. Can someone double check that for me? That's your local min. So let me just double check the math there. Okay, so that's it. That's confirmed answer there. That's your local minimum. That's the point. Probably your teacher might let you just get away with x equals for a local min, but you really should give the point. That's your local minimum value, or the y value at least. Or f of negative pi over 4 equals negative root 2. That's an acceptable way as well. Okay? So if you have to find local max or min, first derivative, sign analysis on the first derivative. Or find the first derivative, find the critical numbers, then find the second derivative, plug those critical numbers in, do the second derivative test.